And I know that when you were taking course to study passive environments, you mostly took course from salt marshes. Yeah? So can you maybe describe what are the mechanisms behind the salt marsh formation and what's the importance from scientific point of view as in studying past climates? I guess they contain precise record of past environments.
The salt marshes that you mentioned is one of the areas in which we would have a depositional story of what happens when the rocky coast erodes and it breaks down the rock by wave action, storm action. The sediments move to places that the sediments can build up. The rock material, the sediments move to depositional centres. And the marsh would be one part of that story. The estuary of a river would be another part. And of course, marshes and salt marshes are part of estuaries. So it's a complex of deposition environments. So part of the work I'd have done would have been coring, drilling down and coring down through that sequence of sediments that shows this story of infilling as the outer coast breaks down. And that is as sea level rises. And so as sea level rises and deposits build up in these areas of estuaries, for example, or in our marshes, or in the areas behind sand barriers, in lagoons, for example, another depositional environment we would drill, then we have a story, a past story, that charts the pattern of sea level rise and sea level change, up and down, and also it charts the depositional story, which is the erosional depositional story, and it charts the style of our coast, the energy signals of our coast.
So would it be right to say that if we have a layer of sand in the core, it means it was a marine transgression, so sand was brought in from the offshore, and then if we have a layer of peat, in simple terms, then it's terrestrial environment?
Yes, in broad outline, except your sand can often, of course, mean a somewhat higher energy signal, which means there's more wave action. So it could be
a single storm event rather than sea level rise.
Exactly, it could be a storm event and not sea level at all.
How do you distinguish between these two?
That's a complex story. It's more that, as you said, coming back to the marsh, maybe better to answer it from that point of view. The marsh supports vegetation and a much wider animal ecology attached to the plants as well. And that organic material builds up and under the right circumstances can form an organic layer, perhaps developing into a full peat, an organic material, the peat, and the peat grows, and then perhaps you would have an increase in the rate of sea level rise. In the simplest scenario, an increase in the rate of sea level rise, which brings on your rock coastal sediments, which then transgress or invade across those organic materials of the marsh. And so you have sandwiched between times of rapid sea level rise and the deposition of silica, sands and muds and inorganic materials. Sandwiched between that material would be evidence of a time when perhaps the sea level wasn't rising quite so fast and storm action wasn't so significant, that allowed the marshes to build up and become colonized by plants and animals. And that's preserved in your peats, sandwiched between your layers of sand and clay and silt. So you have these sequences, and one of the best places in Europe for this would be the Netherlands, where that story was first really developed. But it's also part of the story which we've developed here in Ireland, within our estuary environments, for example, and in the lagoons behind the big sand barrier systems that we have along our coasts.
That's actually another thing I wanted to ask. I noticed that in many locations, salt marshes would be fronted by sand dunes and broad beaches. Why is that the case?
Coming back to our story of rising sea level, which is why I think sea level is a really good starting point for coasts. It's one of the most fundamental of controls to where a coast is in any particular point in time. Not particularly what it looks like, but where it is in that movement from the bottom of the oceans to the land surfaces. So why we have sand barriers, for example, along our coast, or along the coast of Australia, another great example, or along the coast of Angola, it's because as sea level has risen, it's moved the loose sediments in front of the wave action and the current action and the tidal action. So sediments are moved around in our coastline by waves, currents, tides, storms, and they're moved into depositional centres. And if it's sufficient supply of that material, they can build up into barriers, sand dunes, for example, which are then again modified by the wind coming off the sea surface. So we have this process of wind and waves that build our sediments up into supratidal barriers, which can stretch for kilometres and kilometres along our coasts. Long Strand is a little one on the south coast of Cork. Tecumshin and Ladies Island Lake is a lagoon in this much longer one of the Wexford coastline. And then we have others around our coasts. Now those modern day barriers are the most recent expression of where sea level is, because offshore we'd have had, in the past, before they were drowned by rising sea level, we'd have had those barriers offshore. And it's been a migration of offshore barriers onto our present day rock surfaces, our land surfaces, and that's where we see our modern day barriers. But in the past, those barriers were offshore.
So they've been moved by waves and
They've
tides?
been moved by waves and tides and storms and other drift processes, current action, for example. And so we would have perhaps sometimes have overstepping of those barriers and actually the drowning of the barriers, and they're still there, preserved off our modern day coastline in 10s, 20, 30 metres of water. Now we have very few...
And acting as actually natural wave breakers.
Of course, yes. Now those really don't exist for us. We've never so far been able to demonstrate them. But off the east coast of the United States and off the coast of Australia, where wave energy in some places is lower, then we're able to demonstrate overstepped and drowned barrier systems. But for us, our storm energy, the energetics of Ireland's coast is such that it looks as though they've all been removed. And it's a different process of transfer, migration and transfer of our sands and sediments onto our modern day coast. Sometimes it's referred to, it is rather a simple picture, of a carpet being unrolled, a rolled up carpet being unrolled onto the land surface as the sea rises and pushes those sediments, unrolling the carpet onto the coast. Now, that, as I said, is a very simple picture. The specialists can dispute that one, but that's perhaps a good idea.